Probably the most common type of aerosol container used around the world is the tin plate can. This is made from steel, which is then electrolytically coated with tin to provide a protective layer to reduce the risk of corrosion. In addition to coating the steel with tin, one or more layers of lacquer can be applied to further protect the steel substrate from the formulation sealed inside the can. Tin plate aerosols are primarily produced in three different designs: two-piece drawn and wall-ironed cans. The ones pictured here show cans produced by this process, which have a separate top and bottom component fixed onto the drawn container body. Three-piece straight-walled cans. Although not that common, these are still used in some retro-type products and for industrial applications. Three-piece necked-in cans. The necked-in cans are designed so that the top and bottom components sit within the outer diameter of the body of the can, meaning that when the overcap is fitted, there is a smooth transition from the side of the cap to the side of the can. This is by far the most common can design and the one we will focus on for the remainder of this presentation. Three-piece cans, as the name suggests, are made from three separate components which are then fitted together: the top or cone, the body of the container, and the base or dome. Industry has standardized on 5 diameters, which are shown on the slide. These diameters then vary in length to change the brimful capacity. That is the total volume of water which can be filled into the container. The brimful capacity available from can manufacturers is between 140 and 1000 millilitres. However, it is important to note that the brimful capacity is not the volume you would fill into the can when it is put onto the market for sale to the consumer. Aerosol regulation in Europe requires cans to be able to resist a certain level of pressure to ensure they are safe. Can manufacturers offer their product in 3 pressure variants, which are shown on the slide. To know which can pressure you require, you need to know the pressure of your formulation, including the propellant, at 50 degrees C. Once you know this figure, you must then multiply it by 1.5 to establish the working pressure of the container you need. You must then add an additional 20% to this figure to establish the burst or rupture pressure for your product. Here is a worked example. You calculate or measure the pressure of the formulation you have developed as 6 bar at 50 degrees C. The working pressure of your container will then be 6 times 1.5, which is 9 bar. If you then add the 20% you need for the burst resistance, you have a total of 10.8 bar. This means that you can use a 12 bar can to ensure you have the right margin of safety for the pressure resistance of the container for your product. The top and bottom of the can are stamped out from a flat sheet of tin-plated steel. The steel used for the top and bottom is often significantly thicker than that used for the body to give sufficient strength to the container during transport, for the manufacturing process of the final filled aerosol, and during distribution. The stamping process involves a number of stages, as the shape of the parts is very complex and it is important to maintain a consistent wall thickness for the component. We will now explain how tin plate cans are manufactured. Starting with a flat sheet, which is often printed with the marketer's design and the safety information, a tube is formed. The tube is then welded along the 2 open edges to seal it. In the early days of tin plate can making, this would have been done with lead solder, but nowadays it is done by a high-speed copper electrode in a continuous production process. This creates the side seam, which you can clearly see on all 3-piece tin plate cans, as a dark line running down the length of the container. The welding parameters must be strictly controlled to minimise the heat applied in the weld area, but must also ensure that the metal creates a good enough join to contain the pressure which will be put inside the can, and that there will be no leakage. The top and bottom of the tube is then shaped in a process called necking and flanging. This creates the shape to which the top and the bottom components can be attached. This component is referred to as the can body. A sealing compound, usually liquid latex, is put around the outer edge of both the top and bottom. This is used to help create a gas-tight seal on the final can. The top and bottom components are then fitted to the can body. The two edges of the body and the top and bottom hook over each other and are then pressed in a controlled manner to create the double seam. As with the weld, the formation of this double seam is critical to ensure that there is no risk of leakage and that the can will resist the right amount of pressure. You now have an assembled 3-piece aerosol can. So, why would you use a tinplate aerosol can? Because the base material is steel, you can make a very strong can which can resist the pressures needed for aerosol products and cope with the rigours of manufacture, distribution and consumption. Printing the flat sheets of steel allows for a very high quality graphic application before the body of the can is formed. The neck form, or bead, where you attach the valve, is very strong and very consistent, which helps when crimping a valve onto the can. Steel is a ferrous metal, so it can be held and moved easily with the help of magnetic conveyors and other equipment on the production line. Tinplate aerosols work best with products at the alkaline end of the pH scale. However, it is very important that you carry out long-term compatibility testing to ensure that any formulation and propellant you put inside an aerosol will not degrade the container or change in any other significant way during its expected shelf life. There are a wide range of different sizes of tinplate cans available from a number of different manufacturers. As the base material of the can is steel, tinplate containers tend to be amongst the most cost-effective options when looking to pack an aerosol product. Steel is also very easily and very widely recycled. Tinplate cans can be customised through a range of different processes. This includes embossing and debossing and shaping via a number of different processes such as die necking and blow forming. Finally, because industry has agreed on a set of standard diameters and heights, there are a wide range of off-the-shelf components available from various manufacturers which will fit onto a 3-piece tinplate aerosol can. Thank you for taking the time to watch this BAMA training video. Should you have any questions, please do not hesitate to contact the BAMA offices via the various routes shown on screen.